Okay, we're looking at finding the inverse of an exponential or a log function. Recall that to find an inverse in general, this is where we said you're going to switch x and y and solve for y. So, in our first example, we're trying to find the inverse of an exponential function. So we're going to switch x with y, so we're going to have x equals 4e to the 2y, and now our goal is to solve for y, which means you want to get y all by itself. So first let's divide over that 4. And now if we are going to undo an e, we said that we're going to need the natural log. So what we do to one side, we must do to the other side. And that x over 4, if you'd like, you can think of it as 1/4 times x, or you can keep it as x over 4, whichever you prefer. So we're taking a natural log of each side so that this e will be dropped, and now we're left with the natural log of 1/4 x equals 2 times y. That 2y just drops down from the power, and so our last step to get y alone, we would divide by 2. So the natural log, all this divided by 2. Okay, or you can write this as, if you'd like, 1/2 times the natural log of 1 over 4 times x. So this would be our inverse equation. Okay. Next example here. Now we see a natural log in our function, but the process still starts the same. We're going to start by switching x with y. And we need to solve for y. So again, we're trying to get y alone. Notice there's a plus 5 attached to it, and then it's part of the natural log. We see that minus 7 on the end. Well, why don't we add that over right away? So in order to get this y alone, we're going to have to first remove that natural log. Well, because we said that e to the x and the natural log of x are inverses, okay, because they're inverses, they're going to undo one another. So in the previous example, we took the natural log of e to remove the e. In this situation, we're going to drop an e underneath as a base so that it'll wipe out that natural log. Alright, and again, it stems from the fact that e to the x and ln of x are inverses. So that means they're going to offset each other. So we're left with e to the x plus 7, and now this y plus 5 will just drop down. The natural log is gone, and from there we would subtract over 5. Now when we subtract over 5, it's not going to be part of the power. We're not going to say e to the x plus 2. Alright, it's not part of your power. Alright, so this is as far as we can take it. Okay, that would be your inverse. Okay, one more. We're looking to find the inverse, and then after that we want to find the domain. So let's switch x and y like we've been doing. We need to solve for y. So like before, let's add over that 8. Now we can drop the parentheses if you'd like around that y minus 11. Alright, it's just kind of helping us organize it, but you don't have to have it there. There's nothing to multiply it by. So you have e to the y minus 11. So we need to get rid of that e so that we can eventually get y alone. So to do that, we're going to take the natural log of each side. We know that by doing that, the natural log and the e will offset each other. Now be careful over here on this side. If you write this like this, it looks like you're only taking the natural log of x and then adding 8. We want to take the natural log of the entire quantity. So you absolutely have to have your parentheses around that entire quantity. Alright, so then from there it would equal the y minus 11. You could then add over 11, alright, to get your y alone. So this right here is my inverse. And its domain, well, that means possible x values. We said in class that the natural log function, or a log function in general, has a restricted domain. Alright, you cannot log 0 and you cannot log negative numbers. So you can only log positive real numbers. So this inside piece has to be a positive real number. So if you were to take that and set it equal to 0, we're going to get negative 8. So that is the starting point. So x must be greater than negative 8. Okay, that's our domain, or negative 8. Negative 8 to infinity is another way we can express our domain. Again, we are not including that negative 8 because it would give us the natural log of 0, and that is undefined. Again, can't log 0, can't log negatives. So if you were to plug in something like negative 7, alright, adding 8 to that would make it positive. If you were to plug in negative 6, negative 5, so on, alright, that would make it a positive value. But anything less than negative 8 plugged in for x would give you a problem with your domain. Now this plus 11 on the end here, sometimes people want to try to add it on to that 8 and turn it into plus 19. Don't make that rookie mistake. We're only taking the log of x plus 8. This plus 11 on the end here, that's just going to shift it up 11 units. Okay, so you would take your natural log function, this x plus 8 on the inside would shift it 8 to the left, and that plus 11 would move it up 11. That's if you were comparing it to the original ln of x graph. Okay, that's it for now. Goodbye.